Hello dear friends, welcome to Humble Mark Academy. In this video guys, we shall be looking at a qualitative study of the Kirchhoff's law of electric circuits. Guys, this is a very important area in physics that most students find it very difficult to understand. But friends, I promise to make the entire concept very easy for you. Great. So guys, before we get started, I want us to introduce ourselves. I am Omenjo Macarius guys. My Christian name is Macarius. In this channel guys, I take complex science problems, the ones that are very difficult for students to understand. I break them down into tiny pieces such that any student, be it in a junior secondary, in a senior high school year, even those in the university guys, can use it to boost their grades in their exam. But friends, before I do that, I need your permission to do that. Okay, I need your permission. And guys, permitting me simply means that you are just going to press the subscribe button, because by that guys, you are permitting me to help you to pass all the exams you want to pass, because I can only do that once you permitted me to do so guys. And by the permission guys, you're subscribing to the channel. And friends, turn on your bell icon to get notified, such that each time I upload a video guys, you are going to be the first person to get notified. And friends, it took me quite a lot of time to produce this video for you. Okay, it took me quite a lot of time to get this done. All I want you to do friends is to please press that like button beneath the video. That is your own gift to me. That is a way that you tell me that you found the contents so useful. Thank you very much guys. All right, let's go straight to the video today guys. Let's dive straight into it. Okay friends, all right, here is the circuit that we have here on screen guys. Here's the circuit. So guys, the original problem was asking us to calculate just the reading of M1, but I've decided that we should calculate the current that is going to be flowing across each of the branches of this circuit we have here. So guys, for exam purposes, all you need to do when equation like this is presented to you is by drawing the circuit again on your paper. Okay, you have to draw the circuit again, because this circuit you're going to have here will be displayed on the question paper, so you have to draw the circuit. Great. All right, this is the diagram we have here guys. So now the question wanted us now, the question we saw initially on the terminal guys, wanted us now to calculate the current across each of the branches, right, before getting the value of the reading of M1. All right, but the question on the paper itself was asking just for the reading of M1. We are going to do both. All right, so guys, to get each of the currents, we need to first of all know the currents that we are looking for. Okay, and before we do that guys, we have to know the direction of each of the currents. Since the equation did not indicate the current directions, we have to do that ourselves. Now, by so doing guys, we have to identify which of the cells here, or better still, which of the sources here has a smaller value, because the source with a smaller value obviously has to be doing what? Great. It obviously has to be receiving current, while the cells with large values have to be what? Delivering current. Great. So in this case guys, since the 14.0 volts is the largest, it has to be delivering current. That is, the current has to be moving out of the 14 volts. Since the 12.0 volts is bigger than the 6.0 volts, it also has to be sending away current. So the current has to be leaving it. It has to be a source which delivers current. Great. So that's what we have. Great. Then friends, since the 6.0 volts is the smallest among all the cells, it has to be receiving current. So in this case, the arrow has to be pointing downward. Great. So now guys, since we have succeeded to insert now all the current directions, let's give the current names. So in this case, since I have E1, it will be so good if I can just maintain here to be I1. Great. Since current has a symbol of I, so here has to be I1. The current that is flowing through this branch has to be I1. Then the one flowing through this other branch, since here is also E2, so here has to be I2. You can name it in any way you want, okay, in any way guys, but I've chosen to be consistent. All right, then now here I have E3, so I can put this guy here to be E3. Good. That's what we have. That's what I have. All right guys, now that I have it set up, all I have to do now is to apply my Kirchhoff's law to solve this problem. All right, so guys, keep in mind that the Kirchhoff's law works in accordance with the Ohm's law. Okay, they both work in accordance. So in this case guys, I'm going to be using the Kirchhoff's current law. the Kirchhoff's current law, which simply tells me that at any junction in an electric circuit, the algebraic sum of all the currents entering the junction is equal to what, guys? The algebraic sum of all the currents leaving that same junction. Now, guys, let's be practical. Do you see that I1 is, if we look at, take the junction M, okay, this junction M, which is the same junction I'm talking about here. If you look at this junction M, right, you can see that what I1 is entering this junction, right? I2 as well is doing what? Entering the junction. But I3 is doing what? Leaving. So Kirchhoff's law is telling us that what? I1 plus I2, since they are both entering, it has to be the same like what? I3. So in this case, we are going to have I1 plus I2 equals to I3. That's the first equation that we have. We can call that our equation 1. Good. Alright, now guys, since we have 3 unknowns, means we need 3 equations to solve for 3 unknowns, right? Great, we need 3 equations to solve for 3 unknowns. So guys, in this case, to solve for our, to get the other 2 equations, all we have to do now is to apply the Kirchhoff's voltage law, or the Kirchhoff's or the Kirchhoff's loop law, or the Kirchhoff's voltage law. Like I said, either the Kirchhoff's voltage law or the Kirchhoff's loop law. Great. So now, guys, in this case, the Kirchhoff's voltage law simply talking about summing of all the various potential difference drop across each of the various resistors, which has to be equal to what? The sum of all the EMFs of this our circuit. So the Kirchhoff's law in its condensed form, guys, simply states that the algebraic sum of all the EMFs in any closed circuit or in any closed loop has to be like what? The sum of the potential difference drop. Okay, wait. So guys, in this case, this is our direction. We are going to be moving in this direction. So guys, this is our loop 1. Our loop 1 is simply going to be the portion of the circuit, this portion from here. We have from here like this. Okay, this is our first loop. We can call it loop 1. You can call this other guy loop 2. Good. But let's finish with loop 1, guys. So we are going to start at this point. Let's just take this point as a start. You can start anywhere. Okay, anywhere, guys, you can start. So I've chosen this point for us to start. And since the current is flowing in this direction, I'll also choose to go for the direction of the flow of current, such that I'm going to be having potential difference drops. All right. So guys, I can see that the current is flowing in this direction, right? But friends, from Ohm's law, the Ohm's law simply tells us that what, guys, that the potential difference is equal to what? The current times the resistance. Great. That's why we need this law, because we are going to be summing up what? EMFs, or the potential differences across each of the various components that we have in this circuit. We are going to be summing their potential differences, and by so doing, we need the current and the resistance. Great. So guys, the potential difference across this 5 ohm resistor, we can see that the current is flowing in this direction, right? And guys, important note, please take note that current flows from where? From a high potential to a low potential. Great. So since the current is flowing in this direction, I can say that here has to be what, guys? A high potential, and the tip of the arrow has to be what, guys? A low potential. So since it flows from a positive potential to a minus potential, there's a potential drop. And that potential drop, that potential drop, friends, means what? A negative. So here's what? Negative of this voltage. Okay, the voltage drop across 5 ohm has what? Negative. So what's the voltage given as IR, where I is the current, R is the resistance? So we are going to have negative. Our I is simply what? What current is flowing through the 5 ohm resistor? It is what? I1, right? So we are going to have negative I1 times R. The R is what? 5. So we are going to have minus 5 I1. All right. That's what we have now, friends. Then since the current has entered now this section, there's no resistor here, so we don't bother about ourselves. Now we are at this cell. Okay, we are at this cell. We are at this cell, guys. So in this case, we are going to say that this our small stroke means there's a negative potential, and the biggest stroke, guys, means a positive potential. Remember, we are crossing over to the cell. We started with this word with the negative potential, right? And we have ended up having what? A positive potential. That is, we touch the small stroke the first, and we've touched the bigger stroke the last, so there's a potential drop. Keep in mind that here we learned from what a positive to a negative. That's why there was a potential drop. But in this case, we are learning from a negative to a positive, there's a potential increase. So here has to be what, +6. We can add the votes, guys, but it's not important. It's not important for now. Okay, it's not important for now. So this is +6. Then now, guys, the coin is flowing like this. Again, don't forget the coin is flowing downward. It has arrived at this 8 ohm resistor, right? Again, guys, it flows from a positive potential to a negative potential or to a very low potential. So in this case, there's a potential drop. Okay, since we have touched a negative, a positive, and ended up having what? Ended up touching a negative. So there's a potential drop, and it comes with what? A negative. What's the potential difference? IR. What is I? I is a current that is flowing through this branch. What current is flowing, guys? I3, right? Can you see that I3 is flowing here continuously? I3 flows here continuously. Great. So this is now going to be a negative 8I3. All right. Then now, guys, keep coming. The coin now is at this junction now. It now comes now to the left. So this is how we have now. It has arrived at this 2.0 ohms. So again, it flows from a positive potential to a negative potential. There's a potential drop. So in accordance to this Ohm's law now, it becomes what? -2I1. Since I1 is still the current that is flowing through this our branch. Okay, great. Then now, guys, keep coming. This is where we are now. The current has arrived this 1.0 ohms. The current which is here again flows from a positive potential to a minus potential. There's a potential drop. So we're now going to have -1 times I1. Then now, guys, we have arrived at the cell. Okay, the cell now we are now touching the negative terminal, right? And we have touched the positive terminal the last. So there's a positive potential. So we're going to have +14. Since we have arrived now at this point we started, we simply equate everything to 0. Great. That's it, guys. Friends, I hope you found it. I hope you understood the concept, right? I hope you understanding, guys. So keep watching the video, so you're going to understand everything we are going to be doing here today, so that if the similar question like this comes, or any other question as far as Ohm's law is concerned, guys, you should be able to answer it so well. So, guys, don't forget to like the video, friends. That motivates me a lot. That motivates me so much, guys. Please give the video a thumbs up. Okay, it goes a long way to motivate me to keep producing more great content. And friends, please share the video out with your friends so they can have access to great content like this that can help them so well, guys. Thank you very much. All right, friends. Now, if we simplify this our expression a bit, we are going to have -8I1 minus 8I3 equal to -20. If we divide all through by -4, we are going to have 2I1 plus 2I3 equal to 5. Great. We can call this our equation 2. Now, guys, we have equation 1 and equation 2. We need equation 3 before we can be able to solve, right? We need equation 3. By so doing, guys, we are going to consider loop 2. So now, guys, we apply Kirchhoff's voltage law now for loop 2. This is loop 2, guys. Don't forget, this is our loop 2. Okay, this is loop 2. If we start now at this point, let's say we start at this particular point. We started here, right? We could start anywhere. Like I said, guys, anywhere. So if we start here, guys, and we're moving in this direction, that is in the direction of flow of current. This is how the current moves, like this. Again, guys, the current flows from where a positive potential to a negative potential. There's a potential drop. So based on what we did, guys, the Ohm's law says that V is equal to what? IR, right? The I in this case is what, guys? I2, right? Because the current that flows is I2, the resistance is 2, so we're going to have -2I2. All right, guys, we are coming. So when we arrive at this point now, guys, this is how the current is flowing. We arrive at this our cell. This is a negative potential, positive potential. We leave from negative to negative. We arrive at positive. There's a potential gain, right? So we are going to have +6. Then now, guys, we are at this 8 ohm resistor again. The current now is flowing from flowing through the 8 ohm resistor. Again, it flows from where a positive potential to a negative potential. So there's a potential drop, which is going to be -8I3, since I3 is the current that flows in this branch. Then now guys, we are at this point. This is how the coin now comes now in this other direction. Again, it flows from a positive potential to a negative potential. So there's a potential drop. So we're going to have negative 2I2. Since I2 is a coin that is flowing through this branch. I2 is a coin that flows through this branch. We're going to have negative 2I2. Then guys, this is where the coin now is. The coin now is at the 2 ohm resistor. Again, from the positive potential to a negative potential. So it's a potential drop. So it has what guys? Negative 2I2. Alright. So now it has arrived at this cell guys. It has touched the negative terminal and touched the positive terminal. So the terminal that it touches the last goes to the sign. So we're now going to have plus 12. Since we have arrived back at this point, we simply equate everything to 0. Great. So guys, by so doing, we are therefore going to simplify a bit. But friends, keep in mind that this is the direction in which we are moving. Okay, this is the direction. Let me just indicate it. This is our direction. Okay, that's the direction in which we are moving. That's it. So it is now going to, if we simplify a bit, we are going to have negative 6I2 minus 8I3 equal to negative 18, because 6 plus 12 gives you 18. It goes to the left, to the right hand side becomes negative 18. So dividing all through by negative 2, you are going to have 3I2 plus 4I3 equal to 9. Wait. So we can call this our equation 3. Alright. So friends, I hope you understand. I hope you understood so well, guys. Like I said, if you did understand, guys, please give the video a thumbs up. Okay, guys, just a simple thumbs up will mean the world to me. And guys, like I said, I need your permissions in order to help you to pass your exams. The permission I'm talking about, guys, is the subscription you subscribe. Okay, kindly subscribe to the channel so that you're going to have permit me enough to keep helping you in passing all your exams. Thank you very much, guys. So now guys, let's now solve all these our equations now to get the various values of I1, I2, and I3. Are you ready, guys? I'm ready. Let's go. Great, friends, great. So here are the various questions. I have them displayed here on screen. Here are they. So guys, let's start by solving. Let's start with this guy. So in this case, guys, we see that we have I2. We don't have I2 here. We have I2 here, right? We have I1 here. We have I1 here. We don't have it here. So in this case, guys, it is also good for us to make I1 the subject. By so doing, we are going to have. So if we make I1 the subject from equation 1, guys, we are going to have I1 to be the same like what, guys? I3 minus I2. Alright, now guys, we are going to put this, our I1 equal to I3 minus I2 in equation 2. By so doing, guys, we are going to have 2 into our I1 is what? I3 minus I2, right? Which is plus 2I3 equal to 5. So friends, keep in mind that all our physics is over. Okay, our physics is over for now. All we have to do now is to apply the maths, and I believe you guys can do it, so I'll just do it, guys, for formality's sake. So guys, simplifying so well, guys, we are going to have 4I3 minus 2I2 equal to 5. So we can call this our new equation. We can call it our equation 4. All right. So guys, you notice that we have I3, I2, right? Only. We also have I3, I2. So let's bring this guy together and solve as a pair of simultaneous equation. Let's solve it. This is our equation 3, guys. So guys, to solve it, since we have 4I3, we can solve by elimination, right? So by so doing, we are going to take equation 3 minus equation 2 minus equation 4, sorry. We are going to have 4I3 minus 4I3 gives us 0. Then we have 3I2 minus 2I2, which gives us 5I2. Then 9 minus 5 gives us 4. So guys, dividing all through by 5, we are going to have our I2 to be the same like what? 4 over 5, which gives us 0.8 amperes. Alright. So guys, that's the current I2. So guys, if you found the video useful, guys, if you found it so useful, if you learned something from me, guys, please leave a comment in the comment section down below, guys. Let me actually know. Okay, wait. All right, guys, so friends, in this case, if we bring forth our I2 equal to 0.8 amperes and we put in any of the equation, guys, any, in this case I've chosen my equation 4. By so doing, guys, we are going to have 4I3 minus 2 into I2 is 0.8, so we have 0.8 equal to 5. If we solve for that, so guys, we are going to have our I3 to be the same like 0.65. That therefore implies, guys, our I3 becomes 0. Sorry, guys, we are going to have this be 1.65 amperes. Wait. So, guys, that's the value of I3 when you solve. All right. So, guys, to solve for I2 becomes very easy, right? To solve for I1 becomes very easy because we said our I1 is equal to what? I3 minus I2. So now, guys, we can simply say that from I equal to I3 minus I2, it therefore implies our I1, guys, we put in a value, so we're going to have 0.9. Keep in mind that I3 is 1.65, I2 is 0.8. If you subtract these two, you're going to have 0.9 amperes. Wait. So, guys, those are the values of the current I1, I2, and I3. But, guys, we need to get what the reading of M1, right? Now, guys, let me ask this question. Now, is the meter M1 an ohm meter? Is the meter M1 a voltmeter or an ammeter, guys? Guys, what do you think? Please pause the video and think for a second. Great, guys. So, guys, in this case, the meter M1, guys, is a voltmeter. Why a voltmeter? Because the question did not say it is a voltmeter, guys, because what, it is connected in parallel. Okay, it's connected in parallel to this 8 ohm resistor. Keep in mind that the voltmeter is always connected in parallel across any circuit combination. Why is it that? It is so because the voltmeter has what, guys, has a very high resistance. Okay, it has a very high resistance. So it is always connected in parallel such that current can still flow despite its presence. If this M1 was connected in series, we would have said that what, guys, M1 was what? An ammeter. But in this case, M1 is in parallel. That therefore means it's a voltmeter. So the question simply wants us to get the potential difference across the 8 ohm resistor. By so doing, guys, since we know the current that is flowing through the 8 ohm resistor and we know the value of its resistance, we can calculate its potential difference. In this case, guys, we're going to use about Ohm's law to do this. So, guys, in this case now, we are going to term that from Ohm's law, or that from Ohm's law, guys. Ohm's law is simply telling us that V is equal to IR, where V is the potential difference, I is the current, R is the resistance. That therefore implies our V now becomes our I, the current that is flowing through this. So, guys, the current that is flowing through this the current that is flowing through this our 8 ohm resistor, guys, has to be what? Has to be 1.65, guys, not 1.75. Friends, please make the correction, okay? Please just hurriedly correct it. I'm sorry, guys. I'm super sorry. I'm very sorry, guys, for this mistake, okay? I'm very sorry. Here has to be 1.65, guys, not 1.75. It was a typing error, guys. I'm sorry, guys. I'm sorry. All right. Then the resistance is what, guys? 8 ohms, right? So if we plug in everything, guys, based on this 1.75, guys, we're going to have our answer to be 14. But friends, if you do it, you're going to have a different answer, okay? And that different answer is the correct answer, not this one. Because I've made an error here by writing 1.75 instead of 1.65. Wait. So, guys, that's what we have. So, friends, I hope you found the video so useful. If you found it useful, guys, like I said, a simple thumbs up will go a very long way. A very, very long way, guys. It will go a very long way. So, guys, please give the video a thumbs up. That goes a long way, guys, to motivate me a lot to keep producing more great content for you, okay? More great contents. Thank you so much, guys. Thank you so much, and I hope you found it so useful, guys. Like I said, I need a permission to help you pass your exam, and that permission, guys, is by clicking that black subscribe button beneath the video and turning on your bell icon so that each time I upload new videos, you're going to be the first person to get a notification. Great. Thank you so much, guys, and have a blessed day.